Yes, ready. Start பண்ணலாம்.
Okay, so hello everyone. In today's session, we will go through about pasta threat modeling framework. So before going, I would like to let you know that this session will be very much interactive. I would like to keep it as an interactive session rather than just me alone talking everything about what's in the slide. So I would like to keep this as an interactive session. So I would ask questions during the session and which might be easier ones and which might be answered only by security professionals. So I would suggest you to participate in those questions, and so it will be useful for your learning. So before going ahead, has anyone in this call performed threat modeling before? I would like to know the numbers here.
I have.
Okay. Anyone else? Okay, I'll take it as a no. So, threat modeling is basically a process which is done in the design phase of the software development lifecycle. So, in software development life cycles, we have various phases, right? The first one will be requirement gathering, and then design, and then you code the application, and then you build it, and then you deploy it, and then you test it, and then you monitor it, etc. In each and every phase, whenever there is a security aspect is involved, it's called shift left security. So basically, what it means is we are designing the security from the leftmost phase of the software development lifecycle, starting from the requirements phase and going till the monitoring phase. So this threat modeling exercise will usually be done in the design phase of the secure software development life cycle. So threat modeling is a process wherein we will try to identify threats that belongs to an application or a system, and we will also try to prioritize the threats that are identified, and then we will also suggest mitigation strategies, and also we will verify the existing controls that are in place. So before going further ahead into threat modeling in detail, this is an open question since it's a basic cybersecurity question. So can anyone explain about the three things which I am asking now, which is threat, vulnerability, and risk? Can anyone define these three terms?
I think I'll explain what I know. So a threat is
Sure, sure.
possibly an opportunity for a vulnerability. So it's not existing yet, but there's a window. There's something open. There's no controls over there. So there is a chance for there's risk now. And then when you do implement, let's say, your software without considering any controls, that risk would eventually, it will turn into a vulnerability. So I think that's my understanding. You can correct me if I'm wrong.
Um, Kind of okay. So vulnerability, we should when we define these things, usually it should start from the vulnerability. So a vulnerability is the weakness that that is present in an application or a system or a network or whatever it is. And you explained correctly about threat. Whenever a vulnerability is exploited and it poses a risk, then it's called a threat. And then the risk is basically the impact uh, that a vulnerability gives
Yeah,
when a
that can be
vulnerability gets
the
exploited.
risk level. It can be high level, low level, or medium.
Yeah, yeah, that's true. The risk can factor depending upon the risk assessments. Usually, it's ranged from high, moderate, low.
Yeah.
That belongs to a different area, which is risk assessment, which we will little bit cover during this pasta model. So these are the three basic definitions that one should need to know when they come into cyber security. I thought that some fresher would come ahead and explain this, but yeah, it's fine. So this is very much
Bro, I'm also a fresher, bro.
okay. Cool. Then that's great. Thank you. So yeah. So why these things are important in threat modeling? Everywhere each and every page we will touch these three things because these are all the some of the components that belongs to threat modeling. So when it comes to threat modeling usually revolves around four major questions. So the first, I think it's derived by Adam Shostak. The first question is what are we working on? Then the second is what can go wrong? Next is what are we going to do about it? And then the last one is did we do good? So the first thing, what are we working on basically is the application or system or network, whatever that we are threat modeling. It might be anything, but we need to have a good understanding of what we are trying to threat model from several perspectives. Like we should understand the business perspective, we should understand the basic security compliance perspective, uh, we should understand who will be the users, functionalities, etc. And then the next is what can go wrong. Here, this is the main part of threat modeling. So where we will try to identify the threats that to occur in that specific set that we are doing the threat modeling. And then the third is what are we going to do about it? Is basically the mitigation strategies and validating the existing controls that are already in place. This is one of the important phase of threat modeling because from the name threat modeling, people usually think that it's just about identifying threats. But the main thing about identifying threats is how we are going to mitigate those threats. That's the main aspect of threat modeling. That's the main outcome that will be used, and it will be the feedback loop that will be used throughout the shift left security. And then the last thing is about how did we do good. This comes as a perspective, and it's to assess how we did the threat modeling. So basically, is our mitigation strategies are really useful? Did we do any additional proactive approaches, or are we trying to reuse this threat model? So, what are all the benefits and profits that we will be gaining from the threat modeling? Is basically answering the fourth question. And threat modeling has various frameworks. One of the most common framework that we used to see is RAID. It's a attack narrative framework, and then you have pasta. This is not something like an eatery, but I guess the guy who created it was a fan of pasta, and then he tried to name the framework in such a way that it, it fits into the name of pasta. And then we have vast. This is a I would say this is kind of a proprietary one because it's used by a tool called as Threat Modeler. They are a company on their own. They have this model called VAST. It's mainly an agile-based threat modeling approach. And then the other the other threat modeling framework is DREAD. DREAD is basically a risk assessment threat modeling framework. Both Stride and DREAD were founded by Microsoft, and then Pasta is found by a company called Websprite. There are a few more threat modeling approaches that do come, but currently Stride is the most commonly used one. And why I am going to teach Pasta today, I'll explain it now. So basically, when it comes to Stride, Stride stands for spoofing, tampering, repudiation, information disclosure, elevation of privileges. Denial of service and elevation of privileges. It's basically an attack narrative approach. When they built the framework, they did not come up with several things. like prioritization of threats, risk assessment techniques, and then they did not bring any value addition. It's
Sorry, bro.
basically
1 minute.
they.
1 minute. Bro, நீங்க மியூட் பண்றீங்களா? சுப்பையா இல்ல அனிருத் உன்னால மியூட் பண்ண முடியுமா? ஓகே, நைஸ். ப்ளீஸ் கண்டினியூ.
Okay, so basically, Stride is an attack narrative framework. For that, companies have developed their own processes in order to implement it in their organization. But with respect to Pasta, it was developed after Stride. I think it's around 2013 or something. I'm not exactly sure when this came. But it came because mainly Stride fails in most of the areas generically. But with processes, Stride is actually better. But Pasta as an inbuilt process mechanism, it has basically 7 phases, and 7 phases contains several great things that can be implemented within the threat modeling cycle. Um, yeah, let's get into PASTA. So PASTA stands for Process for Attack Simulation and Threat Analysis. I felt that this should be named first with threat analysis, and then and it needs to go with attack simulation, because first we need to perform threat analysis in order to identify attacks, and then only we can do attack simulation. Inside these kind of things like attack simulation does not exist at all. It's basically treated like a one-off, and people don't do anything meaningful using it. They just do the threat modeling, and then they forget getting feedbacks or iterating it with other phases of shift left security. So, Pasta has both threat analysis, which basically means identifying threats and then suggesting mitigations or countermeasures for the identified threats. It also allows us to map each threats with vulnerabilities and then attack vectors, etc. And then it also suggests us to perform attack simulation. So whenever we identify threats, we need to use it somewhere, right? So the one main thing where we usually use is we identify threats and we use it for mitigating those threats. We will be passing it along to developer teams, software architect teams if we identify any weakness in the architecture, um, etc. But we don't basically use it in the security phases of the software development lifecycle. Here, it usually focuses on attack simulations, which can be used in certain engagements like maybe like penetration testing, even for source code review, even for each and every phases that we do, even in each and every phase of DevSecOps. Maybe it can be used to uh, bring a new tool or bring a new technique or help us create like a checklist for our penetration testing team, etc. So this is one of the good thing about Pasta. And the benefits of Pasta is it's applicable to everyone. Whereas in Stride, it's just considered as a one-off and it's not treated anywhere. So Pasta helps developers where we will try to identify threats and suggest the mitigations, which will be useful for developers. It is also useful for architects because there is one specific phase where we try to identify weakness across the architecture of the entire data flow diagrams across assets, etc. So it's really useful for architects. As I mentioned earlier, it's also useful for security testers. You can pass along the threat analysis and the attack tree that you develop in Pasta to pen testers, red teamers, etc. And then it also very much helpful for project managers because in Pasta we actually prioritize the threats that we identify using risk assessment. And also, I forgot to mention that the main difference between Stride and Pasta is a risk-centric approach, whereas the Stride is basically an attack-centric approach. It doesn't cover mostly about risks. Companies have deployed their own processes in order to bring risk-centric approach in Stride. Um, like I would suggest you to watch a video from AWS Summit, where Amazon uh, senior I think a staff product security engineer would try to threat model using Stride, where he developed his own processes surrounding the Stride model. And then it's also useful for business managers in order to assess the impact on their business objectives. At the end of the day, even when we do a lot of security things, it's about we do business, right? That's the most thing which is really needed. That brings the revenue, and then revenue becomes the profit after expenses. So this helps everyone throughout the cycle. Bro, can you move to the next slide? So yeah, so this pasta methodology or framework has various phases. So there are totally 7 phases. Each phases is dependent on each other. So without doing one phase, you cannot jump to another phase, etc. It's basically an iterative approach. So the first phase is about define objectives, which we'll go in deeper. The second is about define technical scope. This is where we get the technical things from the developers, and the developer team, the business owner, product owner, etc. And then the third is about application decomposition and analysis, where we will split the application into smaller parts. We'll draw trust boundaries, trust zones, etc., which we will get into deeper. And then the fourth is threat analysis. This is the main phase where we identify threats that belongs to the application or system, which is in scope. And then the fifth phase is about weakness and vulnerability analysis, where we map vulnerabilities with accordance to the threats that we identified. And then the sixth is attack modeling and simulation. Here we will try to identify the attacks that corresponds to the vulnerabilities in step 5, and then how we use that as a feedback loop for performing a attack simulation. And then in 7th phase, we do a risk analysis using the outputs from the previous cycles. Here we will try to prioritize whatever threats that are most critical, and then we will tag each and every threats with a risk score, depending upon the risk assessment framework that we use. But here it will be provided with a generic approach. Let's move to the first phase, which is define objectives. Can we go to the next slide? Yeah. Yeah. Yes, this is correct. So in the first phase, there are again several activities within each phase, which we will perform iteratively. So inside the objectives phase, the first thing that we will, first activity that we will do is define business requirement. So here, threat modeling is not just a single person's work. It's a collaboration work. So basically, during threat modeling, in a real-time scenario, a product security engineer or a senior product security engineer would do the threat modeling, and then he will be having several other people like the business owner who helps us to understand the business objectives of the application, and then we will also have the product owner who provides us the summary of the product, like the overall use case of the product, who uses it, etc. And then we will have the developer team who builds the application. It might not be each and every developer, it might be the technical lead. We will also have maybe like a pen tester or as an attack persona, you can say, who will help us to identify threats during threat analysis. And the reason why we include an attack persona is we can threat model any system. It can be any application, or it can be a network systems. It can be anything, right? Even in applications, we have several segmentations: web apps, mobile, thick lines, etc. A product security architect or an engineer cannot be a master of all the fields, but he can have a penetration tester or an adversary persona who can help him to identify the vulnerabilities and the attack libraries that belongs to each and every application. And then we also need some defender persona. The defender persona that I would say is like a security champion that belongs to some team who will highlight what kind of current uh, countermeasures we already have. And then they can also take inputs from us when we suggest mitigation strategies so that they can suggest these techniques, or sorry, suggest these mitigation strategies to the developers in a sense where they can understand. Or they might go and fix those code whenever it's needed. So the first slide is not finished yet. Yeah. So the first activity involves the defined business requirements. Um, here, we try to identify the business requirement of the application or the system from the business owner in order to understand where it functions, what's its main scope, and then who will be the customers that will be using it. Is it public facing or is it an internal facing application? Those kind of things we try to understand. We also try to understand the security perspective of it a little bit. We might try to ask them a question like what makes them awake at night, like what are some serious issues that makes them awake at night. Using this, we can understand a little bit of their security requirements. So what I mean about security business requirement is some application might not have confidential information, but there might be an API which needs to be available 24/7. So at that specific perspective, since it does not have any confidential data, availability is the main security business requirement of that application. But when it comes to a healthcare application or a payment cards industry application, there we will have certain sensitive data like payment PCI, payment card info, PHI, patient's healthcare info, and then PAI data, so belongs to customers, etc. So that the confidentiality is the main thing that belongs to the security business requirement. So we need to understand it so that it will help us. It will help us to form the threat modeling in such a way that it helps the business. The second is about define security and compliance requirements. Here we will try to identify certain compliance and the regulatory frameworks that we need to adhere when we do threat modeling. So when I mentioned about PHA data, there might be certain regulatory frameworks like HIPAA, which we need to be aware of. So we need to be compliant with HIPAA, else sometimes we will get into an issue if we don't pass this compliance check. And with regard to payment card industry, we might be going through a regulatory framework like PCI DSS, which we need to take care of in every audits, so that we need to identify and prioritize those threats initially, so that we don't lose some kind of license from the things. And with regards to regions wise also, we also need to identify risks because in each regions there are certain regulatory frameworks like GDPR, etc. Now let's move to the next activity. Bro, can you move to the next slide? And then third is about define business impact. The first thing which I basically defined was the business impact. We need to analyze it whether availability is the main thing that will need to be focused on. Is the confidentiality is the main thing that we need to focus on. This is how we need to derive the impact that causes to the main core business. That's the main aspect of doing the threat modeling approach. Next is a defined risk profile. So this might not be applicable for new systems or new products that we work on. It might be applicable for an already existing product where we do threat modeling. Threat modeling, as I mentioned earlier, threat modeling usually happens at design phase, but usually threat modeling also happens after the application is completely built out. You know, right? Nowadays, previously we were only focusing on reactive security, where whenever an attack happens and whenever the breach gets happen, we focused more on security. Um, so at those times, we never considered about threat modelings and those kind of things. Even at those phases, there were not a lot of requirements with regard to product security or application security. There were a little bit of requirements for SOC, 24 hours monitoring, etc. But now, when companies are turning towards proactive approaches, we need to uh, do the threat modeling in the design phase. But then we also have legacy applications, right? It will have risks and vulnerabilities that are really old. It might have been breached. It might have been breached before. So we need to take those things in concern in order to assess the risk profile of that application. Has that been already breached before? Um, did it have a lot of critical vulnerabilities? So we need to use the outputs of various audits and penetration tests, and then outputs from various scanning tools, etc., in order to identify the risk profile of the uh, product or application. So here we basically define the objective, and we try to understand the requirements and then the risk profile of the application. Let's move to the next activity. Sorry, next stage. Defining the technical scope. So here, in the previous stage, we will most probably be speaking with the business person or the product owner mainly in order to understand the business requirements and then uh, their business security requirement, etc. But here we will be more on the technical side. So here we will mostly speaking with the tech lead of the project, or we will be speaking with other stakeholders like developers, etc., in order to identify the components that belongs to the product or the system. So the first activity in this stage two is enumerate software components. From the name, it's easy to predict that we first need to identify what are all the sorry, not predict. We need to get the information from their tech lead and their developer team in order to identify what are all the components that they have. Do they have it's a high level software components? Do they have is it a 3-tier architecture or is it 2-tier architecture? Um, do they have a mobile app? Like do they have an application front end, an API, database? Do they have an so do they have a log monitoring system, etc.? And then the second activity is about identifying actors and data sinks and source. So here we try to identify who are all the users of the application. Does it have any internal users? Does it have external users? Do we have like a specific user roles? Do we sell it as a pro version or a trial version products? We try to identify who are all the actors that belongs to that application. We also try to identify where does the data to the application comes from. Is it directly coming from a web application front end? Is it coming from a mobile app, a TIC app, or is it coming from an internal system, etc.? We try to identify the sources, and we also try to see where does the data goes. Is it directly going to the database? Is it an internal thick client application that directly appends the data to the database, like in a 2-tier architecture? Or is it a 3-tier architecture where the data gets fed into an application and the application performs, sends those data to the database? So we do these kind of things, and we try to identify the frameworks that are used for the web applications or thick clients or mobile apps. We try to get all sorts of information in this activity. Bro, can you move to the next slide? Next is enumerating system level services. So there might be other dependencies that we might use, right? We might be using some middlewares within the system, like an Nginx reverse proxy or an Apache reverse proxy. We might be using some load balancers. Maybe we are having an internal Kubernetes cluster that's taking care of the orchestration. So we have to get those kind of details mainly. But with respect to an application specific threat modeling, we might not focus more on the infrastructure, but it's good to know. But when we do threat modeling on the infrastructure perspective, then we might try to identify threats in those infrastructure perspectives as well. um, because when we completely do threat modeling, we can do on and on every assets, every middleware that's already present, etc. But the modeling will never end. Threat modeling is also a time-boxed approach. It needs to have a specific amount of time within which it needs to be executed. Uh, so when it comes to agile threat modeling, we do it in every sprint. So within sprints, it's really easy to do. But as I said earlier, there might also be legacy applications which have not been threat modeled before. So in those cases, uh, we will be doing it end to end, and really need to time box it. Okay, sorry. And when it comes to agile threat modeling, it's quite easy since the functionalities are limited, and uh, we also can reuse the previous threat models that are used for certain components, etc. And then the fourth activity is enumerate third-party infrastructure. Here we will try to identify if they are using any third-party services like um, are they using any ingestion systems like Snowflake, Datadog, or are they using any cloud services, because cloud also has shared responsibility models, right? Depending upon whatever services that we use. For SaaS, they literally take care of everything. And then for PaaS, we might have to take care of some things. And there is a lot of shared responsibility model which we need to do. And then with respect to IaaS, most of the things we have to do, they will do things only on the bare bones side. So we will try to assess what are all the third party systems or infrastructures that they use within their application or product. And then the fifth is assert completeness of secure technical design. Here we will try to identify whether all the components that so far discussed are correct or not, and we will try to identify a little bit of scenarios that are pertaining to those third-party systems that are being used. I mean, threat scenarios that are being used. We will also start understanding about the security perspective of the services that are being used. So this is about the last activity of the uh, second stage of pasta. Any questions so far?
No, bro.
Okay, cool then. So the third activity is application decomposition analysis. What I mean by application decomposition is they have not clearly defined in the PPT, but there is a YouTube video from Website which explains about pasta methodology, but they haven't really touched upon in this PPT. So the product can be very huge, right? It can have n number of functionalities. It can have a lot of services, a lot of software components, etc. So you have to focus on one thing at a time. So you take a specific data flow, and then you basically split it up from the entire product, and then you try to threat model that specific uh, workflow or the process. So that's what is called the process of splitting that entire product into small pieces is called as application decomposition. And here there are totally three activities. The first one is about enumerating all the application use cases. It's basically like we may be either talking to a quality assurance engineer or the developer or the tech lead in order to identify the functional use cases of the application. So what are all the components or the features that are present in the application? Let's say we have uh, a money monitoring app like Jupyter app, something like that sort, where it can have functionalities like integrating third-party systems like banks, your GPay, or what else? Your wallets across various places. You can link your portfolio, etc. Those kind of third-party integration is one of the feature. And then you will have a profile functionality where you will have your personal information populated. You can view it, you can edit it, you can delete it. These kind of functional use cases we need to understand. So it's very easy to understand these functional use cases when we do agile threat modeling, but it will be really hard during when we do legacy threat modeling. So there we can get a higher level functional use cases like a profile functionality is one of the functional use case. Third party integration is one of the high level functional use case. The second activity that we will perform in this third stage is data flow diagram exercise and of the identified components. So mostly here, my personal suggestion is to use already used architecture diagrams in order to derive the data flow diagram, because data flow diagrams take a much of time. So definitely for every product during their design phase, they would have drawn an architecture diagram. We must find a way in order to reuse it, because redrawing it again with all the stakeholders and the security architect is a very hectic task. Here, we will try to basically identify the assets. What I mean by asset is each individual component in the data flow. It might be an application database, third-party middleware, WAF, AWS S3 bucket. It can be anything. Asset can be anything. And then there, people also define data store specifically within asset. Wherever you store data or data ingestion applications are called data store. So you have the database called as data store. In DFTs, there is a specific uh, drawing conventions which you can use. Bro, can you go to that WASP slide? Sorry, WASP tab. Yeah, here,
Yeah.
can you go to the data flow diagrams? Here, yeah, you can stop here. So you can have diagrammatic conventions, like you can use bro, it was there. Yeah, yeah, yeah. Can stay. So you can use different conventions for various assets. For external entity, it's like a user or an threat agent, or it can be anything. You can use a different convention like sorry, rectangle. And then for processes, you can have a circle. And then for data store, you can use this diagrammatic conventions. It basically depends upon what you choose, what's best for you. Um, there isn't any specific suggestions over here. People usually prefer doing drawing that data flow diagram in some tools like draw.io, etc. Using in any way that they like. And this is how yeah, data flow diagram would look like. Here you can see there are certain processes and data stores, etc. Right here, we will identify those processes, assets, and the users or the agents, and we will try to map how it's used. You can see this is an example of a library application. So you have your college library website is an asset, and here the external user requested, and then the application sends a response. This is a process, and then the application also stores some data in the database, and then it stores its static contents in a S3 bucket, I guess. That's why they oh sorry, it's in its own disk. Not sure why they have added a separate data store for web pages. Sounds kind of different, but you can consider a database where the application stores it. Um, sometimes there are some implied explanations, right? So you don't need this kind of a data store for web pages on a disk, etc. That's too much of a task to do a very detailed threat modeling. Very detailed DFT. So you can have you can use the pre-existing architecture diagram. It will be a really good one because they have used it to already used it to create the architecture. So you can basically use it. And then the third, you can go to the previous PPT. You can go to the PPT. Yeah. So here comes the main part of the third stage, where we will draw the trust boundaries. It's called security functional analysis and use of trust boundaries. Here we basically identify where the data comes from, what are all the data that is untrusted and what is trusted, what kind of systems that you can trust, what kind of systems that you have negligible trust, what kind of systems that you don't have trust at all. So, firstly, one of the common misunderstandings that I see in industry is people have misunderstanding about trust boundary and trust zones. It is two important concepts in the DFDs. So, trust boundary is basically a barrier between an untrusted entity and a trusted component. So, for example, in the previous diagram, we saw that the external users, like users, were accessing application, right? Bro, can you go to the diagram? Yeah. So here you can see that for trust boundaries, they basically they called it as privileged boundary here. You can call it any way you like. It's usually described as using a dotted line. Here you can see it's drawn between the external users and the application. Application is something you have access to, but can you control the users? No. Can you trust the external users? No, because they can be with malicious intent. They can be a good users as well. So we cannot trust it, right? So you have to draw a barrier between an external user and the application. So trust boundary is a barrier between an untrusted entity and a trusted entity. Here they haven't drawn any trust zones. Um, can you come a bit down? Okay, okay. That's it, bro. That's it. You can go on. Okay, I'll explain it with this diagram so you can visualize it. So assume that this college library application stores its front end in S3 bucket. So and then it also uses AWS Cognito for authentication purposes. Now you have the college library application and its database here. So here you can draw a trust zone for college library and database, because here you have a different level of trust. So trust zones are basically used to express the level of trust that you have in a DFT diagram. So the college application and the library and the database, there are systems that you can control, right? You build the application and you have access to the database. You can delete the entry, you can reboot the application, etc. You have full access over it. But with respect to AWS S3 and AWS Cognito, AWS Cognito is a service that is provided by AWS. So there you have a shared responsibility model, and you have a lower level of trust, right? So it's not owned by you; it's owned by a vendor. So you draw a trust zone for AWS Cognito and AWS S3 bucket. So these are all some of the security functional analysis that you would do in the DFT diagram. So in this stage, you will build a fully functional DFT diagram that will be ready for the next stage of threat analysis. So we can move to the PPT. You can move to the next stage. Yeah, cool. This is the main stage of threat modeling, where we identify threats. From the name of threat modeling, we need to identify threats. So this also has multiple activities. It has around I think 6 activities. The first activity is to find the overall threats that are present in the application. So threats are generic. You identify threats like what if the considering an payment card services industry application, you can consider threats like what if the credit card leakage of credit card information data. It's one of the threat. And then one more threat is unavailability of the payment services application. This is one level of threat. And then next is usage of high privileged user sorry, high privileged user is compromised. This is one level of threat. So here you bring the overall threats. Here you identify the overall threats that belongs to the application in this first activity. And then in the second activity, you gather like a threat intelligence from the internal sources. What I mean by internal sources is you can use the previous penetration testing reports for the project in order to identify vulnerabilities that were previously reported. You can use the security incident reports for the attacks that took place before, which were identified. You can monitor for alerts that were identified by our SOC people. So you can use that as an intel in order to feed your threat analysis further. So let's say that there was a threat previously in an application that an attacker was able to escalate from one user level to another user level. So we have to add those specific threat into our overall threat analysis. And then the third activity is gather threat intelligence from external sources. Here you will list out the possible threats against against your application from external audits that were done for you. It might be an annual pen test that was done by a different vendor, or it was an audit done by some other agency, which you can use in order to feed your threat analysis. Or you can also use publicly available threat intelligence in order to curate your threat analysis specific to your application. And there are certain threats that usually belong to a certain level of systems, right? There are common threats which we'll be seeing in the next to next slide. Can you move down to 2 slides below? The next one.
The next one, right?
Yeah, this one. Yeah.
Yeah.
So these are all some of the common threats. Like in healthcare systems, you have a leakage of administration credentials. With administration credentials, one could literally see the all the patients' data, and then a leakage of patients' data. That's one of the threat. And then you have the leakage of electronic medical records and patient health information. And then yeah, you might there might also be a threat that can give access to life-sustaining systems, basically like medical devices. Like I think a shunt is also now electronic device. I'm not really sure. Maybe if an attacker can get those data, he can target specific attacks. And then we have other monitoring. We have a lot of medical devices nowadays. In India, it's still developing, but in US, we have a lot of medical devices for each and every purposes. And then when it comes to retail, like a payment cards industry, you have certain threats like card holder data, like leakage of card holder data, and the leakage of customers' personal identifiable information. As I said earlier, like downtime of system. These are all major generic threats that belongs to each and every industry, which you can add. So can you move to the previous slide? Here we need to the fourth activity is updating the threat library. So as I said earlier, threat analysis also involves introducing few personas like a penetration testing persona or an adversary persona into the threat analysis zone in order to identify the attack libraries that pertains to certain application. So we might be working on web application, and then we cannot identify mobile application security risks on web application, right? You need to choose a specific threat library that corresponds to web application, that corresponds to mobile application, and then that corresponds to thick client, etc. You need to curate your threat library in order to accommodate your application. And then the fifth activity is threat agents to asset mapping. So here we will first try to identify the possible threat agents who pose a risk to us. It can be, as you can see here, one of the example that they have given for hitting a payment services system. They have given malware author as one of the threat agent, crime syndicate, a state-sponsored attacker, And then we have an insider. Insiders can also be in threat agents. We also need to focus on various insider threats during threat analysis. The one main difference between Stride and Pasta over here is in threat analysis phase, Stride only focus about those uh, six specific attack variations which I prescribed earlier. But in Pasta, you can literally identify threats that are pertaining to anything. Like it's not tied up to specific attack variations alone. You can also go with persistence, privilege escalations, lateral movement techniques. You can literally identify threats and you can do end-to-end threat analysis. You can also think of situations like what if the application has a remote code execution? I mean, the application server is compromised. How can an attacker persist? How do you mitigate those kind of risks also? These things are not covered in Stride. That's the reason it's. I personally feel that it's inferior when I compare it to Pasta. And then in this fifth phase, you compare the threat agents. Sorry, you map the threat agents to assets. So insiders might have access to internal application, whereas external users might not have access to internal applications. Right? They can use that asset in order to do some malicious purpose. And you can see here there is a malware author who needs to install those malware in specific devices. So he's mapped to target entity like POS hardware, POS software, etc. And then you have crime syndicate, or you can consider it as an external threat who will be mapped to your payment card services application mainly. And those kind of mapping, we have to do it in the fifth phase. And then next is about assign probabilistic values around the identified threats. So, so here we try to identify the probability of this threat to take place. So, what is the most probabilistic threat that can occur? Can the application gets down? Is that the most probabilistic threat that can happen? Can the data be leaked? Is that the probabilistic threat that can happen? We need to assess this. We can also use our risk profile, which we built in the first stage, in order to identify what were the risks that we already saw before, in order to prioritize the probabilistic values for these identified threats. So that's about it for the stage 4. Any questions so far? No questions, I guess. Okay. And then the fifth stage is called weakness and vulnerability analysis. Here you will try to identify the vulnerabilities that corresponds to each and every threat categories that we identified. So it also has various phases. The first phase is review and correlate existing vulnerability data. Here we might be using some data like our vulnerability management dashboard or penetration testing reports in order to identify vulnerabilities that were previously identified. We also try to identify the vulnerability that are mostly occurred. We also identify components which had those vulnerabilities in order to map the vulnerabilities to those specific components. So these kind of phases doesn't exist in Stride. You have to basically go with each and every component, and then you need to assign that attacks, etc. But in a process, it's defined here. So basically, for an example, I would say encryption of data in a database layer will happen only over the database, right? So if we identify that as a vulnerability, we can easily map it to the database only. Let's say that we have a SQL injection vulnerability that cannot exist in the database. It might be an application level vulnerability that might impact the data which is present in the database, but it needs to be mapped with the application. So this first activity will help you to understand whatever components that are most vulnerable, and also try to understand whatever vulnerabilities that you already found. And then the next is about identifying weak design patterns in the architecture. This will be very useful for the software architects. What we will do here is we will try to identify vulnerabilities that exist in the architecture, like how is the data in transit being protected in the entire architecture diagram. Is TLS being implemented? Uh, is mutual authentication being implemented for communicating between internal services? And then for data in transit, as I mentioned earlier, when we handle certain sensitive data like payment card services data or PHE data, we need to encrypt those data in the database. If that's not mentioned in the architecture, we can identify those kind of vulnerabilities in this specific activity. There will also be vulnerabilities like non-encryption of disks of the devices that we use. So that's one of the vulnerabilities that where we will try to identify in the architecture level. The third activity is map threats to vulnerabilities. Here we will try to map the threats which we identified in the four stages with the vulnerability. So what I basically mean is when I said about leakage of credit card data is one of the threat. So how can it happen? So you need to think that data is present in the database. So there has to be a database leak. And where can this is the database directly available? Yeah, it might also be there. Maybe there would be a exposed port of the database which does not have any authentication, like anonymous login, using which an attacker can directly access the database and he can get the data. This is one of the vulnerability. And then you have, the famous SQL injection. It's one of the vulnerability that can lead to this, where it might exist in the application, where an attacker would use that SQL injection in order to exfiltrate the entire data and then post it on some breach forums, etc. And then next thread, when we consider about unavailability of the application, here we might also consider um risks like what if an internal Kubernetes pod gets accidentally destroyed. It's one of the vulnerability that we can have. What if an attack? What if the application does not have a rate limiting functionality? Can an attacker literally brute force send a huge number of malicious requests and then take down the server? This is the vulnerability mapping that we do for threats. The third example that I would say is about let's say that we have a threat like an attacker gets access to the application server. So here we might try to identify vulnerabilities that corresponds to remote code execution. Here we might add that the application might be vulnerable to SSTA. The application might be vulnerable to SSRF. Application might be vulnerable to SQL injection. So we will list all the vulnerabilities and then we map it with threats. This is really good because usually in Stride these phases were not mentioned. It's about identifying threats and then mapping with those 6 criteria that were previously identified. And that was previously mapped. Like so here when I mentioned about leakage of sensitive information, right? So it would correspond to variations like information disclosure, and then it might also be corresponding to uh, threat variation like elevation of privilege. So we map those threats corresponding these to the variations that are present in Stride, but we don't personally do threat vulnerability mapping like we do in Pasta. These are all generic approaches, but companies have implemented certain processes in order to map the threats with vulnerabilities. Let's move to the next slide. Next is aligning weakness to the assets, which is called as provide contextual risk analysis based on threat vulnerability. So here we will assign whatever weakness or the vulnerability that we found to the assets that are present in the attack tree. So SQL injection vulnerability can only exist in the application. And then SSTA is also a vulnerability that can present in the application. Let's say we identify a vulnerability for the S3 bucket. we found that any unauthorized users can access the S3 bucket and can get the sensitive information outside of the S3 bucket. So this kind of vulnerability needs to map to the Amazon's S3 bucket. And then, as I mentioned about the unencryption of sensitive information, this kind of vulnerability needs to be mapped to the database. So here we do the vulnerability to asset mapping, uh, and then we and then in the next phase we do conduct targeted vulnerability testing. I'm not sure how many of them doing pasta or especially doing this specific activity. What they mean by is this is a really good approach where we identified several threats during our analysis, right? Uh, Using this, we provide this as a feedback to the previously ran vulnerability scans, and also we will use this as a input. For example, let's say we identify a threat like SQL injection. Now, when we try to curate our SAS scans, uh, are we writing any custom patterns in order to identify SQL injection? When we do that, it's really a good thing, right? So that you can conduct specific targeted vulnerability testing within this phase in order to identify the critical vulnerabilities. SQL injection, maybe you can identify SST things uh, using the SAST tools, and then you can also identify insecure deserialization things using SAST tools, etc. And then you can also curate your DAST scans and then perform at least targeted vulnerability testing. So that's about this phase. Here we basically identify vulnerabilities and then we map it with assets, and then we map threats with vulnerabilities, and then targeted vulnerability testing, etc. In the sixth phase, um, attacking model and simulation. Here we will try to write the attack scenarios for the identified vulnerabilities. So the first activity within this is analyze possible attack scenarios. So in this first activity, we will try to write what are all the attack scenario that can take place for the weakness that we identified before. And let's say that there is a functionality in the profile page. So here we might write an attack scenario like an external attacker uh, injects malicious SQL injection payloads uh, in order to uh, exploit a SQL injection vulnerability. This is some of the attack scenarios that we can write. I think there is uh, a tool which was made by Amazon. I think I have in my notes. I will share it. It tries to map the attack scenarios really easily. So you just have to input your attack agent, and then you have to input your weakness in the threat, and then it will automatically narrate an attack scenario, which you can just even export it as a CSV, and you can upload it to your tracking system like Jira or your any system that you like.
Is that open source or commercial?
Sorry,
Is that open source or commercial?
it's an open source tool.
Oh, so correct me if my understanding is wrong. So based on the tools insights, we ourselves will be able to get an evaluation of the risk poster, and based on that we can map controls in security architecture. Correct?
Can you come again? Your voice is too low.
So based on that tool, we ourselves will
Mhm.
be able to understand the risk posture, and based on that post threat modeling, we can write the controls and security architecture review. Correct? Based on that tool.
No, no, no. It's basically used to write attack scenarios only.
Oh,
So,
oh.
what will that? But it will give you a perspective of what you need to focus. So basically, it will involve inputs from you. You have to enter threat agent, and then the vulnerability, the threat, the threat impact, and then the asset, and then it will completely give you a threat scenario. Like it will give you in a narrative way, which you can add it to your ticketing system in order to view these attack scenarios in the future stages.
Will that be handy for security architecture review?
No. It's usually used to write attack scenarios, just to write attack scenarios. So the tool doesn't do anything other than writing attack scenarios. It's like a template which you can implement. It's actually used by Amazon also. They built the tool. So you can have a template for your attack scenario, right? Even in
Got
penetration
it. Got
testing
it.
report, you can have the template, right? You will first provide the summary, and then the impact, and then the reproduction steps, etc. You have a template, right? Similarly, you can have template for attack scenarios.
Got it. Just feel free to share that in group, okay? Once you remember it.
Sorry?
Once you remember the tool name, just share it.
Yeah, sure.
Thank you.
Okay. And then the next in the next phase, in the next activity is about update the attack library vectors and control framework. So here we will again go with the architecture diagram. We try to identify weakness. Sorry, just a second. Okay, I got confused with my notes. Apologies. So here we will try to see if we have adequate control measures for the attack libraries that we built. So we will evaluate whatever existing control measures we have implemented before. Like for example, some of our product team or tech lead would suggest that we have a WAF which acts as a control for most of the threats. So it's up to us because we are the security perspective, security team. So we know the perspective, security perspective. So we know that it's not an existing, it's just an existing control, but it's not actually a mitigating fact for the vulnerabilities, right? So here we need to assess those kind of things. Um, and then in the next activity, we will try to identify the attack surface and the attack vectors. Also to add another point, the pasta did not include one specific step before. So usually we have to get the existing controls that are in place when we finish the threat analysis. So we can get the entire list of controls that they have, like from the security champion or from the product lead, etc. Like whether they have implemented WAFs, are they using some sanitization for using any third-party libraries like DOM Purify in order to mitigate vulnerabilities like XSS. They can also write existing controls like when I mentioned about AWS Cognito, there are certain misconfigurations that are specific to Cognito, but then the security champion can also mention that this specific misconfiguration does not exist, and they have correctly configured the AWS Cognito and those kind of existing controls that they can write. We need to evaluate these existing controls once we perform threat analysis. But if we obtain these assumptions before performing threat analysis, then our threat analysis would not go really good because we will have assumptions and then we will miss several things. Some might have an understanding that with using just the DOM Purify, the entire XSS vulnerability gets mitigated. But then what if DOM Purify gets a new CVE, which you can exploit and you can get an XSS vulnerability. So that's why we need to keep the existing controls at the last place of the threat analysis, and then we need to validate it. So let's go to the next activity, which is identify the attack surface and enumerate the attack vectors. So attack vectors is the attack scenarios that an threat actor would use in order to attack the system. And attack surface is basically whatever asset that he targets in order to perform the attack. Vector. Maybe he's using the SQL injection as an attack vector in order to attack the web application. And then the database is also one of the component which will be impacted. So the attack surface becomes web application and database. So we do those analysis over in this activity. And then in the next activity, we assess the probability and impact of each attack scenario. This helps us to perform a little bit of risk assessment. So here we try to identify the probability of the attack to take place. Um, for example, let's say that uh, we identify an internal application that we do threat model, and it has a SQL injection vulnerability. So an external attacker will not be able to reach this system directly because it's internally hosted, and the network segmentation is perfect. So the probability of the external attacker to attack this system is literally zero when we consider it from the external perspective. But what if he tried to breach a different system, and then using a lateral movement technique in order to attack this application? So the probability is lower, but still the attack exists, right? So, but whenever there is a public-facing application and it has a SSTA vulnerability or an SQL injection vulnerability, then the probability is a bit lower. So I will also touch upon a different application also. So for mobile applications, the probability and impacts are usually lower because most of the mobile-specific attacks require you to steal a device and then and then making the victim to install a malicious malware into their device in order to exploit certain weakness in mobile applications. For example, you find an exposed activity which you can trigger. Either it might be an implicit intent or explicit intent, but still you need to make the victim to install a malicious application, right? So the probability becomes lower. You need to phish the victim, and the probability of you putting that application in the Play Store is also pretty hard because Google security team also validates that application. So this is how we try to map the probability with respect to the attacks that we have derived in this stage, and then we will also identify the impact of the attacks. So SQL, depending upon this is again maps with the business requirements as well. So with respect to an availability application, if there is no rate limiting or the application does not have any kind of load balancer or a WAF, then the impact is quite critical. And then when it comes to an SQL injection vulnerability, if there is no existing controls and if an attacker is able to exfiltrate the entire data, then the impact is very huge. So we have to map the impacts with the attacks in this specific activity. And then the next is about this is one of the important activity across this threat modeling approach, which is derive a set of cases to test existing countermeasures, which I mentioned earlier. So when here we get the existing countermeasures and we try to validate whether they exist or not, whether they are correctly implemented or whether it's actually implemented in the system. Let's say they say that they have implemented a database segmentation. They have role-based access control in their database system. Then we need to basically go and validate whether it has been implemented or not. Maybe during a security audit or something like that. We need to add this as a input to a different process. And then the next is about conducting attack-driven security tests and simulations. This is why they named it as PASTA. The first line, right? Process for attack simulation and threat analysis. Using whatever attack scenarios, vulnerabilities, and threats we identify, we just go and perform an attack simulation, like penetration tests. Using the attacks that we derived as a checklist, we provide it as a feedback to the penetration testing team, and they will try to see if these threat vulnerabilities actually exist or not. And then it will help us to assess whether these threats really exist or not. But nowadays, I guess I came to know that Amazon has implemented this kind of structure. We are passing the threat modeling feedback to the penetration testing team in order to perform the penetration test. Their product security architect was mentioning in their AWS Security Summit, which is really a good thing. This is where the fourth portion of threat modeling is answered. uh, uh, did we do good? This is some of the feedback that we can take, and then we can use it. There is also one more thing that we can reuse the threat model. Maybe we build our own OAuth SSO or SAML SSO, and then it's used by all the applications. So you just have to do threat modeling on that OAuth or a SAML application just once, and then you need to perform a penetration testing using that threat analysis that you done, and then you can reuse it every time that this has been previously tested, this has been previously threat model, etc., and you can have that safety assumption over here. Let's move to the last stage, which is uh, residential risk analysis and management. This is the risk, as I mentioned earlier, PASTA is a risk-centric approach. Here we will be doing the risk analysis and risk management in this specific activity. So in the previous stage, we calculated the probability and the impact, right? But companies usually use different risk assessment techniques. Some might use MIST, SP 830. It might involve using likelihood, impact, and then the exploitability. So in the PASTA's provided approach, we saw that it was using probability and then impact. So here we use the probability and impact in order to assess the risk. So if the probability for the vulnerability, if the probability of the threat to be exploited is less, and but the impact is high, then the threat becomes moderate. If if the probability becomes high and also the risk is high, then the risk becomes high. So here, companies use different risk assessment techniques, and then they perform their risk analysis. And then here, the last part, this is the main activity that is important for the entire threat modeling process, because the process of threat modeling is to identify threats proactively, and we need to mitigate those risks. So in order to mitigate, we need to identify the countermeasures for each and every threats. We need to go from the bottom-up approach where we try to identify countermeasures for each and every weakness that we identify. What I mean by weakness is vulnerability. So for SQL injection, we must suggest countermeasures like we must use parameterized queries. If we are using ORM, we must use these security functions. Now this can be taken as a feedback by the security champion, and they can add it as a input to the secure coding framework. And then we need to teach the developers in order to use these functions well. And then when it comes to SSTI, we must avoid rendering user input using our rendering template engine. And then with respect to insecure deserialization, we can provide countermeasures. They never deserialize user input. And if there is a business requirement to do it, we need to implement data validation. And then with respect to cloud security risks like AWS, unauthorized access to AWS, then we can suggest configuring IAMs to S3 buckets such that only authorized users can access that. You can also suggest countermeasures like, just a second. I think it's security signing. Usually, the S3 bucket URL will be signed using the S3 keys, and then it will have a signature which will be validated so that only an authorized person can access it. So, so in this is the main thing that we do threat modeling. So we have to effectively do the part of identifying the countermeasures, even though it's the last activity that we do in the threat modeling approach. So that's about the entire PASTA process. Any questions now?
Bro, so this process is, kind of a hectic where different team members have to join their hands and work on this. Like the developers, the architects of the application should, help with application architecture, and the security architects should help with, the overall process. The red team or the VAPT guys have to, do the testing part, and the blue team side, they have to implement and verify the configuration part. So it is kind of spread across different teams, right? So uh, how does small scale company how do they approach this implementation of threat modeling? What is the best way to do that?
Yeah, so this is actually threat modeling is a team activity, as I mentioned earlier. It involves various stakeholders. As you said, it should involve software architects, right? Uh, so stakeholders have to be involved throughout the threat modeling process. If we have to do effective threat modeling, if we do an effective threat modeling, it will be a value addition throughout the entire cycle. I said you the link between threat modeling with other phases, right? Like you can also use threat modeling to enhance your DevSecOps pipelines. You can use this as a feedback loop for configuring your SAST scans, DAS scans, and then even
uh,
for
so,
identifying secrets.
Bro, sorry to interrupt. Actually, the question I asked, or the clarification I want was, how does a small scale company take this into their process? Like they cannot so let's say it's a 30-40 people company, they don't have different teams. So is this suggested for them to implement and work on, or is it suggested for a company which has these teams already established and roles established?
Shall I pitch in? This is Alex.
Yeah, sure.
Yeah. See, irrespective of whether it's a small company or the bigger company, the activity would be remaining the same. Maybe the roles might be integrated within the same primary role. So in a bigger company, there might be 10 to 15 members might be doing, whereas in a smaller company, since the scale of business is very small, maybe the same maybe multiple activity would be done by the same person. So the best way to get to know about us, the maybe you can reach out to your product manager or the business folks. So they are the people who would be owning the business. So I think that could help you a lot. Just my
Uh,
point of view. That's it. Yeah.
and to answer your question, so threat modeling has a lot of return on investment. So for doing effective threat modeling, we need to involve all the stakeholders, irrespective of whether it is a small organization or a big organization. But if you have to do threat modeling properly, as far as I have seen in the industry so far, um, either they do it at the later stage. So whenever threat modeling is also done by consultancies as well. Whenever the companies go to consultancy side, they do it after the application gets into production, which is basically it doesn't give a lot of return on investment for this kind of activity. But when you do it on the from the initial phases, it provides a really good return on investment, irrespective of whether small or large. We can involve the stakeholders for each and every phases. Only involve stakeholders, right? For example, when you consider this pasta, for the initial objectives, you are just going to talk with the business owner and the product owner, and then you need your and as a product security engineer or the product security architect, you are going to understand the objectives from them in a individual call, and then you have to go and have an iterative call with the product team and then the team lead in order to understand the technical scope of the application. And then you have to work with the penetration testing team or the attack persona in order to map the threat analysis way. And then in order to verify the existing controls, you might have a security champion or you might have a team lead who knows a little about security, whom you can contact in order to identify the existing controls as well. So in each and every activity only you are going to contact people and you are going to communicate with people. You're not going to involve everyone. You're not going to involve everyone in every activity. It's just in each and every simple activity you are going to involve them. But if you do this in this approach, it will provide a really good return on investment because it can be used to curate your pen tests. It can be used to curate your DevSecOps pipeline. It can help you to create a really good security maturity model.
So let's say, this small company does not have these experienced people, like security champion and the security architects and all. So is it suggested to go with pasta methodology, or should we go with a simpler one, trying to use an existing threat modeling tool, and feeding the architectures to it, and gathering details from it, and kind of working on those uh, those outputs and recommendations from those tools initially to set the process, and then later developing it slowly, with creation of the teams. And is that a suggested way if we
I think the
don't have?
better process to approach this is there might be people who might be interested to perform this task. So we should put it as a global post across the entire team. If any one of the developer is interested to become a security champion, if a lot of people are interested, then first the process that we need to do is even before doing threat modeling and other things, we need to implement a security training process. First, we need to create a security training in order to train those developers in order to become a security champion. Once we define that, uh, we can come up with this threat modeling approach, because the process of shift left also has various other processes, right? You need to teach the developers what security is, and they need to be aware of security. And we also need to tell the business owners how it can impact the business, what kind of impact that it can cause when a breach happens, etc. So first we need to build a process, and then we can go up with a methodology like pasta, even for stride, right? In order to identify existing controls, you need to have a security champion or a person who at least knows about something that they worked on in security. So when I worked on a very small organization, it was a very small organization, like similar to what you asked, like 30 to 40 when I was working as a developer intern. We had our tech lead who tried to mitigate vulnerabilities that came from check marks. So he tried to learn on his own for WASP ES API, and then he implemented those things on his own. There might be people who will be interested on this domain because
But yeah, that is
mhm.
true, bro. So the important thing that we face in a small organization is people tend to prioritize more on the development stuff. Like the management would suggest keep working on the modules, and they don't kind of don't understand this security, understand the ROI of this kind of implementation without having an impact previously. So if when they get impacted by some security attack, they will know the risk, and they will understand, okay, this kind of impact will happen. So once that is there, then they'll understand the importance of security. But I believe, in a smaller organization, we'll have to give them something to, give them some data to, to even consider, training some people on security champion training, and hiring some people for, architecture, like security architecture, or other things as well, right? So to even convince them to make this as a process, we'll have to give them some data. So to give that data, can we use these tools like Threat Dragon and Microsoft threat modeling tool and all? Will that help?
um,
Yeah,
yeah, I
there are some automated tools which you can use to kind of automate
Hmm.
certain process. Threat
Hmm.
model as a code is there.
Hmm. Hmm.
Uh, and threat model, there is a software called threat modeler. Some tools
that's a
will,
paid tool.
some tools will make the process easier. However, to pull it off, you need a dedicated product security engineer who is doing multiple works,
Hmm. Okay.
identifying threats and trying to attack the part and so on.
Okay.
Without specific, he would be the sole person to pull everything off. Without
Hmm.
that, it's not possible.
Okay. Okay.
One more idea would be if the organization has a little bit of security maturity. For example, they at least conduct annual pen test. Let's assume that way.
Mm.
So annual pen test provides a lot of vulnerabilities which developers will be fixing, right?
Mm.
You can use that input, and then you can create a threat model like this, and then you can talk to the business owners that this threat has this much of impact, and then you can try to convince them that if we do a threat modeling approach like this, then it can bring a lot of ROI. And then you can also tell them that whenever the annual pen test team, maybe a vendor or someone gives the report, right, the developers will be working day and night in order to fix those issues. So we also can suggest at the time that if we um, uh, assign a security champion, like we should convince them that we will provide training for them, at least one person in a team, then it will be really helpful that not everyone will be working day and night in order to fix those vulnerabilities. A single person can be really helpful in order to uh, do those uh, do those aspects or do those mitigations.
Okay. Yeah, bro, that makes
Yeah,
sense. Yeah.
And I have a question here. When you say ROI, means by doing threat modeling, we can have ROI. You mean like we can upfront we can foresee what are the possible potential impact that could lead us to the financial impact? Is that you're saying like maybe future legal litigations or
yeah,
regulatory? Is that the case? Or other than
yeah,
that,
yeah.
is there any other financial benefits that would be which in terms of business
Some
point of view, say when we
sometimes
pitch in, yeah,
sometimes
that is what.
insurance,
Mhm.
security insurance or cyber security insurance, they require these process to be implemented. So that, that might fall in your question as well.
Mhm. Mhm.
Yeah.
Okay.
So basically, we try to identify threats even before they exist, right? That allows us to be
Proactive.
attentive. That allows us to be become attentive, so that we don't get into a huge impact, which will like a security breach, for which we will be paying a hefty amount as a penalty or something. This is one of the ROI. And then the other ROI with respect to process, what I say is, it allows us to do curated pen test for the applications. So you create a threat map, you create an attack tree, and then a pen test team can use this as a feedback in order to identify vulnerabilities, so that it allows us to identify it allows us to identify much more vulnerabilities, and then it also allows us to identify much more vulnerabilities even before pen test. As I mentioned earlier, right, when we write a threat like when we write a vulnerability for a threat like data loss as a SQL injection, we might be writing custom rules as per our code for a SaaS scanner like a SEMGRAP in the SaaS pipeline, so that we identify and mitigate SQL injection vulnerabilities even before they are pushed to the code, right? So it's a good thing. You don't have to fix it in the when it goes to the staging environment, where a pen test team would do the testing in the staging environment, and they come and tell you during your deadline. This is one good ROI that I can see from the process perspective.
Okay. Thank you.
Any other questions?
Okay. Okay. Yeah.
And one query I have is, so can we use the same pasta framework for infrastructure or enterprise threat modeling as well?
Yes, yes, you can use it.
We
You
can
can use
leverage
it.
it.
Yeah, yeah,
Okay.
you can leverage it. It's not tied to any attack variations like Stride is.
Mhm.
Here, when it comes to infrastructure and other things, you can use an attack library like MITRE attack, and then
Mhm.
you can focus on in all the tactics that are present in MITRE as well. You can
Okay.
go with tactics that are not covered basically in Stride, like Stride
Mhm.
only focuses on attack variation.
Mhm.
So, like you have various tactics, right? In MITRE,
Yeah.
you have lateral movement, persistence. What if
Mhm.
you can come up with threats like an attacker sits in our network after exploiting a particular product. So this is a threat for which you can derive certain vulnerabilities. For example, it's still skeleton key vulnerability exists in Active Directory system. We are using old Windows Server systems. Uh, uh, we are we don't have any preventive mechanisms. We are not rotating our KRB TGT keys in order to prevent golden ticket attacks. So these are all some of the vulnerabilities that you can map. You can apply pasta anywhere. You can also apply pasta for assessing vendor risks as well, vendor risks, insider risks, everything. Because when we do pen test, we also onboard vendors, right? What if some of the vendor are malicious and they do something with the data that we have? So you can use this to derive those threats, and then you can implement some regulatory frameworks there and then and there in order to mitigate those risks as well.
Okay, is there any other questions?
No, from my end, I'm good. Thank you much.
Okay. If there is no other question, we can end the session here.
Right. Thank you all for joining the session. I hope that it was really helpful. So, if
Yeah,
you have
நாங்க
any
தான்
questions
உங்களுக்கு
related to,
நாங்க தான் உங்களுக்கு நன்றி சொல்லணும்.
இப்ப நாங்க வந்துருச்சா?
ஆமா.
Right.
Thank you, bro.
Oh, if anyone has any questions related to